What comes to your mind when you are thinking of automation solution? For us, it's a very important business area. The demands placed on modern automation solutions are increasing rapidly, and WFL has responding to this for years. Today, we take a deep dive and talk with Manfred Fahrion about WFL Automation Solutions in detail. Manfred, why has automation become so important in the recent years?
Yeah, it has been important for a long time, but like you said, it became more and more important now, and that's basically related to the need of personnel at the machines. In the past, it was pretty easy to get personnel for the night shifts and for the weekends, and now, you know, with work-life balance, people are not eager to work during the night or even on the weekends. So that's why automation became more and more important. If you purchase a machine, not only a high-end WFL machine, any machine, you want to utilize the spindle time 24/7. And that's where the automation kicks in, so we can use the machine really 24/7.
And what do you understand by turnkey projects?
Turnkey means basically that, like, you know, turning a key, so the customer comes in, turns the key, and everything works, and he doesn't have to interact with the machine or the automation. So the WFL Turnkey Troop, you know, our team, we develop together with the customer specific solutions where not only the machine is included in the automation, but maybe some other processes, buffers, tool changing. So turnkey is more than just loading a machine.
So the reaction is often to replace employees. So, but in fact, they can work more efficiently using automation. So how is this implemented in the customer side?
So the main aim for automation is not replacing people. Okay. The main aim is to keep the product competitive, so reducing the price per component. So our customers, they produce components, they sell on the world market. And in order to be competitive on the world market, the price has to be low, as low as possible. And if you use people to load and unload the machines, that has a direct impact on the price of the part. Like I mentioned before, weekends, night shifts, if you cannot utilize the machine during those times, then the cost per part will increase. And that has a big impact on the company being competitive on the global market. So, you know, the number of employees will probably not decrease, but we will need higher skilled personnel. So running a turnkey system, you need a little bit of higher level of education or understanding of processes.
So the process, what is the project process for automation after inquiry?
Yeah, I have a saying, you know, the customer knows exactly what they want, but they don't know what they need. So they come and they say, oh, I want a robot in front of the machine, you know, for example. And then if you get closer and closer in contact with the customer, you will find out that you know, they need to interact with the machine, like with gauges and measuring and things like this. So the operator has to go into the cell frequently, and a robot in front of the machine is usually some sort of an obstacle. So, and then we offer him, for example, a gantry, which is it's a robot as well, but it runs on rails, and it's loading the gantry from the top, and there's nothing in front of the machine. So, and then they sometimes go, oh, I didn't know that it's possible, you know. And then so you have the loading and unloading to the side of the machine, and during that time when the operator needs to get into the cell, everything is wide open in front of the machine. And then, we start discussions. Sometimes we talk about automatic tool changing. And it's a process, so like I said, the customer has a certain view of the solution, because machine plus robot, you can see this everywhere around the corner. But in many cases, it's more sufficient for the customer to include additional tasks within the cell.
To what extent are the operators' experience and skills taken into account during the project development?
Yeah, this is like I said, this is, it's a process of developing the solution together with the customer. So it's not like the customer sends out an RFQ and we provide a proposal. It's more like, let's discuss. So what are your needs? What is the process? How often do you have to measure? How often do you have to use a gauge? And do you have issues with chips? Or between one operation and the other? Do you have to manually change like the jaws on the machine? Or what is your real need? And in having this discussion, you will, in 9 out of 10 cases, you will see that there is this open eyes, it's, wow, I didn't know that's possible, And that's really what I love about it, to develop together with the customer a customized solution.
And so which automation solutions are available?
Whatever you can pick, it's available. Okay. So we have done HEV systems with a robot mounted on top of the HEV. We would travel with the robot in front of a machine, lower it's like a rack where the robot is sitting on. We lock it, we center it, so the robot is movable, but it's also very accurate because we lock it in front of the machine. We have done robotic systems, of course, with the 6-axis Fanuc or KUKA or any other brand of robot on a slide or fixed in front of the machine, area gantries which run in X, Y, and Z, or line gantries where the machines are lined up. So we do all kinds of different solutions. It really depends on the circumstances, like the ceiling height. Like the ceiling height. So if the customer has a low ceiling, the gantry is sometimes not the right solution because we need a lot of free space above the machine, to travel and go up and down.
Okay. And which one are most used?
So if we are talking about heavy components, like we have several orders right now where the product itself weighs 1,000 or 2,000 kilo, plus the gripper, which is also customized, weighs another 1,000 kilo. So in those cases, we use gantry robots because their payload is much higher.
How do individual components in the automation cell communicate with each other?
We have 3 levels of communication. One is the hardwired communication, which is a e-stop. So you have to hardwire with a plug. The second one is like the handshakes. Jaws open, doors closed, machine ready. This is basic communication. We do this with Profinet. And then we have data communication, where we have in certain projects, we download the NC programs from a centralized virtual server, and we download the programs to the machine, depending on the part which has to be produced next. So that's Ethernet.
A current large-scale project involves multiple interlinking in combination with a gantry loader. How is this automation system configured?
When you mean configured, you mean software-wise, or?
Yes.
Yeah, this was basically same answer like the last question. So we have a high level of host system, which is doing all the data collecting. Then the second level is the gantry controller, which is a Siemens controller for the cell. And then on the next level we have the machines and auxiliary equipment, like we can have a measuring station, a washing station, deburring station, things like this. And the host system we can also provide, which is it's like one level below SAP, like a standard MES system, where we look into the future of the product of the production recipe. The customer wants to produce a certain number of parts, which might be completely different, and we look into the magazine of each machine. We check the tools which are in the magazine. We look at the remaining tool life of each tool, and we double check with the NC program for the next part, which is in the queue, to be manufactured. And we would only load this part into the machine if all the tools with the remaining tool life are in the machine, because we want to avoid that we load a part and the machine is not capable of finishing it. So we would, in this case, we would look for the second highest priority part or the second oldest part in the queue and check this NC program with the magazine and the tool life, etc.
And how much load capacity can be handled?
With a standard design, parts up to 2,000 kilo, because then we have about 1,000 kilo for the gripper. So a standard gantry we're using has a payload of about 3,000 kilo. But right now we have a project we are quoting where we basically double the payload by combining two vertical axes. So right now we could do a project with 5,000 kilo payload.
Okay, and how large can be the workpieces?
I would say, between 3, 4, maybe 5 meters. That's still doable.
For which customers or industries is such an automation solution of interest?
Any industry.
Any industry.
Any industry. Wherever you have, you produce parts, like I said at the very beginning of our discussion, you have to be competitive on the world market. And even if it's small parts or huge parts, you want to reduce the price per piece. And that's where, like I said, that's where automation kicks in. For the long run, you can use the machines much better than manually loading.
How much can the project be customized, or are there certain requirements that absolutely must be met?
Like I said, the payload, if it's a payload of 10,000 kilo, we have to say, sorry, this is not doable with automation at this point. Maybe in a few years, when the robotic equipment develops further. But so if it's really high, it really gets to a limit where automation is feasible. Ceiling height, like I said, that's a point. The available floor space. So if everything is really tight, you need to have a loading and unloading area, ceiling height. These are the things. But so far, I have not seen any project where we got to those limits. So usually you will find a way around it.
And what requirements must the customer meet in order for the solution to be installed?
Customer has to be open-minded, so they have to be, not in a stiff mindset, like I said, be open-minded, and the discussion, open for discussions, and this is what we find is, very often the case, that customers are happy. At the beginning, maybe they're, kind of a little bit stubborn, because they have everything in mind, this is what we want. And then if you get closer in contact, you will see that, there's more to it. It's not only loading and unloading a machine. We can do that too. But we try to have a hybrid solution where there's an added value to the customer, not just loading and unloading.
And how many components can be interlinked?
There is no certain number. We have projects where we have 10 or 12 or 15 stations or machines under one roof with a warehouse. So we like to use a warehouse which is acting like a lung. It opens and closes, so you load the warehouse with a certain number of parts, and then you shut off the light and you leave for the weekend, and out of this warehouse we load machines depending on the available tools, like I mentioned before. and then we finish parts and load them into the warehouse. And when the customer comes on a Monday, he finds a certain number of finished parts. And this is what the aim is usually, to have lights out and still get finished parts.
From order approval to delivery, what is the approximate time frame we're talking about here?
Yeah. So in general, it takes about 2 to 3 months after order placement to get the final layout, because in the proposal stage we are using some assumptions, and then after placing the order we're going to have a kickoff meeting with the customer and talking about all the little details. And then we start with the layout. We get a layout approval, and this process takes about 8 weeks, so 2 months. The first 2 months is engineering and putting a specification together, which is really focusing on the automation and the interaction between all these machines and auxiliary equipment. And then we need about 6 months for manufacturing, so we are at 8. And then we need about 2 months for installation at WFL here in Linz. So we do the mechanical installation, electrical installation, commissioning, software commissioning, handshakes and everything. That takes about 2 months. So 2 plus 6 plus 2. So we're at about 10 months from placing the order to factory acceptance test. And then we do the installation, packing, shipping. So SOP, start of production at the customer site, it's about a year.
Which safety measures or safety settings are in place for such a large system?
It's not only for a large system, the safety aspects are, because we have to certify, CE certify every system, and these are all the same measures. So all the access doors have to have a certain, locking device. We are using safe area scanners on the floor. So if somebody gets into the area, we scan and make sure that after locking the door, nobody is still inside the area. On the robots and everything, we are using like the safe robot programs, or on the gantry, safety integrated, so the gantry cannot travel in certain positions. This is restricted. So we are setting limits and safe areas where a gantry or a robot can only operate. So there are certain levels of safety. So we do the risk assessment, and that will result in certain measures, like on the program. For example, a robot, and there is a safety fence, you can only go with a certain speed to a certain distance of the fence. So you cannot be 10 millimeters away from the fence at high speed. That's not okay if you certify the cell.
So it will shut down everything when you cross the line.
Yes, but by using safe robot software, so the robot cannot even go beyond those limits. So for example, we build like safety.
It's like a cage.
It's like a cage, but around the gripper. Maybe the gripper is like this big. We build safety bubbles around the gripper, and these safety bubbles are used in the safe robot program. And this bubble cannot be closer to the fence like 200 millimeters at a certain speed. And if this bubble is detected in the background when we calculate the kinematics and the path, if this bubble is closer than 200, then the robot would get in an e-stop mode or in a cycle hold mode. But this is why we program for the gantry as well as for the robot safe zones where they can operate. So we are setting limits.
The biggest advantages are saving in production costs, more effective, predictable and reliable production, predictable service intervals, and so on. What else can be added to this list?
Having a sexy system in your factory, No, I'm not kidding. Sometimes it's a showcase. So we have customers, they say, I want to have a nice system I can show to my customers, that I produce the parts with state-of-the-art technology. And if I walk my customers through this facility, I can see their eyes go open, Or I want to attract young people, because, the young people, they want to play with their iPads you know, these kind of things. And if you have a sexy automation system, this is just fancy stuff, you know, and you can attract people joining your company because they have several offers. And if they have the choice between, you know, a company running production like in the 80s or running production like in the 21st century, that's the way to go.
Thank you very much.
It was my pleasure.
Thank you for watching. We hope you tune in for the next episode of WFL Tech Talks.